You have the power to influence others. And in this nugget, I will show you how to use it. Tuning inbound load balancing. By the time we're done here, you will use AS path prepending to tune inbound traffic across carriers. So BGP is a funny world in the sense that it really gives you the opportunity to impact routing around the world. All the internet is really one big network. It's a network of networks all combined together. And as it stands right now, we have our autonomous system. Specifically, it's autonomous system 194068. And inside of that autonomous system, we have attached the public subnet 63.232.144.0/24. A subnet originally assigned to us by Level 3, used to be called CenturyLink, and granted through both a SWIP record, a shared whois, and a letter of authorization to be advertised out the IO blend, which is now called Iron Mountain. It's funny how many changes happen. And being advertised out Cogent. Now, when it comes to autonomous system control, we have total control of how our system routes. It's our system. If I want to send all the traffic out to Level 3 or out to Cogent or load balance between all of them on the outbound traffic, that's no problem at all. I can control that. However, when we're trying to influence the inbound traffic, now we're talking about impacting other people's routing mechanisms. Now, as it stands, the other autonomous systems of the world belong to those people. Technically speaking, if they want to be able to set routing to do whatever they want, they can. If they want to be a black hole and drop all the traffic going through their system, they can. However, BGP gives us the power to influence routing on their behalf. I'm going to make the assumption that you've heard of the BGP attributes. If not, this is really what comprises your ability to select what routing algorithm or what routing direction BGP takes. I just went to Google and typed in BGP attributes, and one of the top hits took me here. It looks like some guy talking about all those attributes, and he has a pretty good list right here of what those attributes are. You can see weight, local preference, where the route originated, the AS path length, and so on and so forth. These are all, so when somebody says, well, how does BGP choose the best path? There is no simple answer to that question because there's rules that every router goes through. Cisco routers, Brocade routers, Juniper routers, they're all slightly different in how they go through these algorithms. But in the case of Cisco, which is what this guy is talking about, and I know he's talking about Cisco because this attribute of weight is a Cisco proprietary one. In the case of Cisco, it says, okay, the number one way we're going to find the best route, it's whichever BGP route has the highest weight. I think I chewed on my tongue when I said that. Has the highest weight. The second one, this is actually an RFC standard, is whichever route is tagged with the highest local preference. The third one, and you can see down and down and down the list that we go, right? So when you have this BGP table that's sitting right here, it's showing that there is one network, 1000/24. I'm assuming this is set up in a lab environment. And it says there are 5 different paths to get there. How's it going to figure out what the best path is? And you can see down at the bottom, it chose this one. And the reason it chose that one is because of some series in this attribute list broke the tie. And BGP will break the tie. You can see at the very bottom of the list, you're starting to resort to just random rolls of the dice. You know, whichever one is the oldest. Let's take that path. Okay, that's tied. Okay, whoever has the higher route. Okay, fine. Whatever neighbor has the highest IP address, that's going to break the tie because you know that you have different neighbors and they have different IP addresses. Nothing will survive that tiebreaker to allow BGP to figure out the best route. So as I flip the slide over, you can see that my plan here for influencing inbound traffic is really focused on, as the title of this nugget implied, the AS path. See, BGP in all its sophistication has all these different metrics that it can use. But one of the most common tiebreakers for the best route is actually the AS path. Why? Well, because the weight you as an administrator have to set. The local preference you as an administrator has to set. Where the route originated from? Well, that's often set by a variety of sources. It could be from internal, it could be redistributed. There's various origins that the route can have, but most of the time that's all the same. So the AS path is one of the strongest attributes to break that tie. It's one of the first tiebreakers. Here's what that means. I mentioned just a moment ago that our autonomous system is 19468. This is the network that we're advertising. When that is advertised out, it automatically stamps the autonomous system onto that advertisement. It's actually BGP's loop prevention. I'm going to send that out, say 63 route. I'm going to stamp it with this little autonomous system. I'll just put 19 there because it's really small. And it's going to go up to level 3. Level 3, I think, was autonomous system 209, if I remember right. As they hand it off, they're going to stamp onto that AS path. That's why it's called a path. That little autonomous system, so 209 will be tacked on there. It'll go around the different internet. And eventually, it's going to come back to level 3. There's loops all around. I guarantee you they have different connections all over the place. So they're going to get that same route back. And the loop prevention says, oh, this has already been to my autonomous system. Delete. I'm not going to accept that route. Same thing here. If I send it out and it comes back in cogent with autonomous system 19460, oh, that's 63, right there, 19468, my system will reject it because it will see it as a looped route. That's the sole function of the AS path, but that attribute is used as a strong metric because shorter AS paths are considered better than longer AS paths. Now, it's not talking about total length as in character count. It's talking about how many autonomous systems are in there. So when it leaves my system, it has the 1, and that 1 is the 19468, and every autonomous system it passes through will add itself to that list. So when it gets to, let's just say Sprint is over here, it has a connection through Cogent, it has a connection through IO Blend. It might look and go, okay, well, I can go this way, and I've got 1 autonomous system number, 2 autonomous system number, or I could go this way and I'd have 1 autonomous system number and 2 autonomous system number. It's tied. Bad example, but let's just say Sprint goes out here through a whole bunch of other autonomous systems before it actually gets to Cogent. It doesn't have a direct connection. Well, it's going to see the AS path of 2 autonomous systems going this way, whereas going this way, maybe it's 5 autonomous systems. And it's going to say, okay, this is the better route. I'm choosing that path. That's the way that metric works. So the way that we can influence that is through that method called AS path prepending. The way it works is pretty tricky, and I almost wonder if somebody originally patented it as like, this will be tricky. I can see if I can make this work. You take your own autonomous system, which is 19468, that's what ours is, and you actually stamp it multiple times in a row. So it's the same AS number many times on the paths that you would prefer people not use as much. So maybe you have a higher bandwidth connection through level 3 than these other 2 carriers. The rest of the world doesn't know that. They just know they see your route however they got it. So you might stamp your autonomous system 5, 6, 20 times onto these other carriers to try to influence the other systems of the world to say, wow, that's a really long AS path. If I go this way, I'm going to prefer the shorter way, which is this. Now, you're not guaranteed that it'll work. You're trying to control other people's systems. But keep in mind, there's hundreds of thousands of routes in people's BGP tables. They're not really going to focus on you as, man, I can see that guy's doing AS path prepending. I want to stop that, although they could if they really wanted to. But what makes you so special? You're not. And so through that obscurity, you can add that AS path number on there and really influence the routers that are probably using default algorithms to go different directions. Let's take a look at what we've got. I'm going to pull up my network monitoring system, and you can see I've zoned in right here on our 2 edge routers, Brocade Public Edge 1 and 2. Now take a look at what we've got. Let's see, where do I begin? Let's look at this one. So I've got Public Edge 1, Iron Mountain traffic. So I'm going to click on that, and since I've enabled BGP, that is now actually handling load balancing, both inbound and outbound traffic on both of those. Let me clear off these cumulative sensors at the bottom. Oh, actually, you can't even see my sensors. There we go. My inbound and outbound is in the various shades. You can see that I'm averaging around 8 to 10 megabits per second with some spikes that take me around to 48 megabits per second or so, right? That's coming in on Iron Mountain. Now I come over here to CenturyLink, bring that guy up. And what I notice, this is kind of cool. What I notice is since I made this change, it's kind of mellowed out. I don't know if maybe it's just me. Maybe I'm looking at this big clump of traffic. You know, I'd be able to go historical and really see if that's happening. But it feels like it's gotten a little more balanced, I would say, since I deployed BGP. I have nothing more than just a gut level, okay, that's what it looks like feel, right? So that's one side. Now, look at this other side. I'm going to go to the Public Edge 2. You see Iron Mountain traffic on there and Cogent traffic on there. Now, again, going back to our design, Level 3 or CenturyLink connects to that left router, Cogent connects to the right. Iron Mountain connects to both. Now, if I bring up the Iron Mountain traffic right here, you can see that about the only thing it's doing is the inbound. That's because, going back to my design, I've got VRRP set up between these guys. This guy is the active router, so all the outbound goes there. This guy is the passive. He's just waiting for him to die. So the only thing that's happening is the inbound traffic's coming here. There should be no outbound at all. And if I look, let me just clear off all the channels and show inbound and outbound. You can see the outbound is literally nil. It's that pink line at the bottom. Nothing's happening. Inbound, you can see balancing out. Now let's look at Cogent over here. I click on Cogent. I'm going to bring up the 30-day graph because I want you to see something. Look at what happened here. This is when I rolled out BGP. This was pre-BGP, happening on the 15th and 16th. That's our normal traffic pattern that you can see reflected all the way back historically. Right here was where I went into that Friday night. This is the weekend. This, I think, is exactly where I deployed BGP because that's where I messed up and caused a little brief outage. It's brief, kind of brief, but look at what the traffic has been since we've come back online. Because Iron Mountain is now handling some of that traffic, you can see my traffic is cut down significantly, probably because Iron Mountain has more connections than Cogent, so the AS path looks better through Iron Mountain than it does through Cogent. Remember, Iron Mountain is a blend of carriers, whereas Cogent is just a single carrier. Now for me, myself and I kind of prefer Cogent to be handling a lot more of that traffic coming in because IO blend or Iron Mountain blend comes at a premium. I don't want to go into my bursting territory and my bursting rates because I've got too much traffic coming in. So what I want to do is I want to make IO blend look a little worse to the outside world so that more traffic starts coming into Cogent. One more resource I want to give you before we start is a BGP looking glass. If you just Google BGP looking glass, don't go to that one. BGP looking glass. Let's just hit enter on there. The one that I use quite a bit, let's see, where is it? Right here. Hurricane Electric. I love this looking glass. I should define. A looking glass allows you to see the routing tables of other networks around the world. So we can kind of peer into somebody's routing table with the whole purpose of seeing how our network shows up. We want to see how the other networks of the world reach our own network. This looking glass allows me to pick, North America. So I'm going to say, sure, Hurricane Fremont will be one. Let's go with Phoenix Nap is another one. That's one real close to me. And we might as well throw Europe in there as well. Let's go with Geneva, good old Switzerland. Then I'm going to come over here and type in my network, 63.232.144.0, and I'm going to say, show me the BGP route. I want to see the routes from these. Hit probe. Whoops. I need to throw a subnet mask on there. /24. There we go. Probe. Boom. And just like that, it gives me and displays to my screen the 3 different routers that I've shown, the 3 different areas of the world, and what their BGP table looks like. This is Hurricane Electric. This is Phoenix Nap. And this is little Geneva out in Switzerland. Why is that so small? Probably because they're pretty small. Take a look. What we're seeing is their BGP table. Hurricane Electric is saying, I've got all these different ways that I can get to your network. So what are these? These are all their BGP peers. But the way that it's found that's best is this one. Now I can look at that AS path and go, okay, there's my AS number, 19468. 12025, that's Iron Mountain. Oh, it even, look at that. As I hover over it, you see it pops up. It says IO data centers. They haven't changed it yet. Iron Mountain right there. And then Iron Mountain is connected to whoever 3356 is, which it just hovered over. It says, oh, that's level 3. So they've got a direct connection. So it's saying that's the one that I'm choosing as my best. Now look at some of these other ones. 209, that's CenturyLink, right? Whoops, I clicked on it. Stop. No, go back. There we go. I've recovered. That right there is CenturyLink's AS. And you can look down the list. Now, take a look at some of these that show 19468 times 2. That is AS path prepending. Why? Because I've already done it. At least I had it back before I deployed Iron Mountain as a third carrier. But now what I'm seeing is at Hurricane Electric, at Phoenix Nap, and even in Geneva, Switzerland, they're all preferring the route into me through IO data, which is not what I want because I pay more for that bandwidth, thus solidifying that I want to change that metric. Here's how we do it. I'm bringing up my primary router. I'm going to do a show IP prefix list just to demonstrate that I already have a prefix list that matches the network that we're after. I'm going to go into global, create a route map. I'm going to say route map, and we'll name it Iron Mountain IM-AS-Prepend. I always type my variables in all caps just so I can recognize them in a show run. I'll do a question mark and do a permit sequence number 10. The first thing I want to do is tell it what to match. So I'm going to type in match IP address defined in the prefix list. Copy, paste. And I'm going to say this guy right here. That's the network I want to match. Now I just happen to name my prefix list that same name and match that one network. I press enter. Then I want to set the AS path prepending to, and you can see it allows you here to do a maximum of 8 numbers that you want to prepend. Now, you want to make sure that you always prepend your own autonomous systems. I've made the mistake, because I've been going too fast, of putting in the carrier's autonomous system, which isn't good because they'll immediately see your route as a loop and reject it. I'm planning to create a series called Fun with Internet Outages by Jeremy Cioara. It's probably a 150 video series with the number of outages I've caused over the years. So I'm going to start off by putting my own autonomous system 3 times. 19468 space 19468 space 19468. So I've already added 4 hops if you count the original autonomous system that I stamp on there by default as I send this network out to Iron Mountain. Now I haven't attached this route map yet, but I will. Press the enter key, exit back out. Speaking of fun with internet outages, you don't want to forget to put a second line on there saying permit 20. I'm going to leave it blank. And what that does is say anything else is permitted. Check it out. I'm going to do a show route map. And you can see that I have, where is it? IM-AS path prepend permit 10, which says this is matched, and I'm adding all these AS numbers. But if I didn't put this permit 20, it would say, okay, everything else is cut off. That would cut off all those misfit routes, the /27s and 28s, essentially anything that's not in this prefix list from being advertised via BGP. That'd be a problem. My last step is going to be going into each one of these routers, because I'm going to have to do the same thing on Brocade too. Otherwise, it just makes the secondary path look way better. And attach it to the neighbor. Let me again do a show IP BGP summary, get a quick list of the neighbors, show run, include router BGP, and everything having to do with that neighbor. Enter. Looks good so far. Go into global config mode, router BGP, copy and paste, neighbor 7244, route dash map, Iron Mountain AS path prepend. Whoops, need to specify the direction first. Outbound, Iron Mountain AS path prepend. Boom. Now notice it's saying, hey, you got to clear that with at least a soft outbound. You won't kill the whole neighbor relationship, but at least that'll reset it. Before I do that, I'm going to go and do this on the secondary router. I'll keep the video live just so you can get a review of those commands really fast. Show IP BGP summary. There's my Iron Mountain neighbor on this side. Show IP prefix list. There's the prefix list I need. Global config. Paste in route map, Iron Mountain AS prepend. Match the prefix list. Prepend the autonomous systems. And permit the remaining networks. Router BGP, neighbor right there. Route map, outbound, Iron Mountain AS path prepend. Bail out of here. So on the secondary router, I'm going to do a show IP BGP neighbor, zone in on that guy, and say advertise routes. I want to see what routes I'm advertising to that neighbor. Looks good. You can see the AS path is pretty much blank for all of them because I'm the one originating this. Now I'm going to do a clear IP BGP. Neighbor such and such. I'm going to say soft outbound. Got to be really careful with that command. If you just press enter right there, you tear down the whole BGP neighbor, thus tearing down any routes that you have coming in or out through that neighbor. So dangerous. Soft outbound just reapplies the filter and resends. Hit enter, hit the up arrow, and just see if I'm advertising the routes a little bit different. Check it out. Yeah, baby. I'm appending that autonomous system path to this guy 3 times. And I can feel pretty good about jumping over to the other router now, doing the same command, but slightly different IP address. Verify the advertised routes, and we are now prepending along the way. I'm going to give this, 10 minutes or so. Go back to that BGP looking glass and see if I've affected any change with the direction the other networks of the world are taking. Oh man, I didn't even have to wait 10 minutes. I waited 1 minute and I went and refreshed the data. Look at what's happened. The 3 different locations. So I've got I think that's Fremont. It's Hurricane Electric either way. This is Phoenix Nap, and this is Switzerland. They've all bailed on the IO data path in favor of going direct through CenturyLink. So if I were to check my bandwidth right now, I would probably see a big shift of all the traffic going over to the CenturyLink link. Did you get that? CenturyLink link. Right. All right, let's take a look. I'm opening up right here. Let's open CenturyLink's graph. CenturyLink traffic. Look at this. Right now, 1:20 p.m. I can see, let's just clear off some of this traffic total stuff. I can see the inbound traffic goes shoop, right up. And I bet if I look at the Iron Mountain traffic, I'm so excited. Look at the Iron Mountain traffic, I bet it just dropped down or just sat there. I might just have to give it some time. I'm bouncing across a little too fast. Let's go look at the Cogent traffic over here on router 2. Bring up the graph. Oh, look at that. We're kind of like zoop, right there, right around that 1:20 p.m. And let's look at the Iron Mountain traffic on this side. Oh, look at that. Oh, come on. Okay, there's got to be some proof in that pudding. I know we're still early and all that, but look at that. It's like, woo. It's like a little roller coaster slide right down. So my thought, just gut level from looking at that looking glass, I think I prepended that path a few too many times. Maybe we should drop a couple off. So this nugget is going totally way too long. This is not a nugget. It's an epic novel on inbound route balancing. But I hope if you're doing this in the real world, it helps demystify some of this for you, because this is the game you play. You add autonomous systems, you remove autonomous systems, and just watch. You look at that looking glass to see, okay, am I kind of balancing it out? Because right now I kind of swung the pendulum the other way. Iron Mountain is now seen as the boo hiss. And these two are now preferred as the inbound routes. And actually, maybe that's good. Iron Mountain costs too much for their bandwidth. Sorry if you're listening, guys, but give me a cheaper rate. Just saying. Anyway, let me wrap this up. You now know how to use AS path prepending to tune inbound traffic across carriers.